Well, hello everyone. My name is Daniel Moyer. I'm one of the sales support trainers here at Briggs Stratton Energy Solutions. Joining me today is Randy. Randy's going to be taking a look at the Q&A. Chat has been disabled, but the Q&A is open and available. Comments and questions. Additionally, one more housekeeping item is that this course is approved for NABCEP credits. So if you're here for your NABCEP credits, we will be issuing them at the end of this presentation. Our email will pop up. Go ahead and email us your full first and last name, and we'll go ahead and email out those credits as well. Lastly, the webinar is being recorded, and we will send out a copy of the recording plus all the slide decks at the end of this presentation. Today's topic is off-grid living, and a really exciting topic. It's something that when I got started in the industry, it's something that was kind of near and dear to me. I worked at a company called Sunfrost, where we made DC refrigerators, and a lot of people living off-grid still had DC architecture in their houses. So let's go ahead and jump into it. First off, a couple of upcoming events. Well, the most upcoming one is going to be RE+. It's in Las Vegas. It's coming up in just 2 weeks. If you're going to be there, let me know. I'll make sure I have a special gift for you at the booth, and we'll hope to see you there. Another event, one that I always love, is the NABCEP event. This year it's going to be in Milwaukee, which is home to Briggs & Stratton. And we're going to be doing an event probably the day before the NABCEP starts at our headquarters, which is just right there in Milwaukee. And we're going to be doing a museum tour plus some other training sessions as well. So if you're going to be in Milwaukee, let me know, and I'll make sure that we get you invited to come take a tour of Briggs & Stratton headquarters as well. One thing I wanted to bring up, I'm not sure, and if anybody here on this call has ever met or know of or been involved with Solar Energy International and Johnny Weiss, he was a great person for our industry, especially in the off-grid market as well. Solar Energy International, if people aren't familiar with, is one of the leading training organizations for the solar storage, wind, micro hydro industry. And so there is going to be a celebration of Johnny's life at RE+. It's going to be at the Solar Energy International booth. So that'll be on Wednesday, 4 to 6 p.m. So if you're going to be at RE+ and you know of Johnny, I hope to see you there as well. Before we get it started, I do want to promote our Elite IQ Installer program. This is a program that we invite anybody who has installed our batteries in the past to join. You will receive rebates. There's other benefits like trip reimbursement charges. We're going to put you on our maps, get you some referrals, and we'll send you some swag as well. If you have not installed our product yet, we are offering a $1,000 first-time install. So go ahead and get your first install done, and then upload your proof of purchase to our website, to the rebates section of our website, and then we'll go ahead and cut you a check for $1,000. And then after you get that first install done, any installation after that, we give you $100 back per battery as going forward. And then we'll additionally give you a $500 rebate on that second install. So call us, email me, let me know, scan the QR code on the screen, and we'll get you into our installer program. Let's just kind of talk about a little bit off-grid. You know, back when I worked at Sunfrost, we always got subscriptions of Home Power magazine. So for those who don't remember, magazines were a thing, and magazines, one of my favorite magazines we got was Home Power. It was, they sent it out every 2 months, and this magazine, one of my favorite parts of the magazine was the Code Corner, but I went back and I kind of looked at, what was the history in 2021, and, that was, over maybe 20 years ago now, but that's not that long ago, and even just 20 years ago, I mean, look at that ad right there. That just for a Siemens 100-watt solar panel is $477. So $4.70 a watt just to buy the module, let alone, installing it. And then look at some of those MPPT charge controllers. So we've come a long way. And this, obviously isn't adjusted for inflation either. But if you think about it, remote homes and cabins, people living off the grid, were some of the first consumers to use photovoltaics, batteries, inverters, charge controllers. And really, it's progressed, right? The times have changed, and now most of the business is in grid tied. First, mainly it was in grid tied inverters, string inverters or micro inverters, where we just send back to the grid. But as we see that a lot of the net metering policies have changed, we're starting to see more batteries and solar photovoltaics being installed in grid tied homes as well. A lot of these off-grid homes also incorporated generators, and we're going to talk a little bit about why we're going to pull a generator into a lot of these off-grid systems as well. Sometimes they just had a generator, right? And you would just start up the generator during the day, and you'd shut the generator off when you went to bed at night. But a lot of these off-grid homes recognized they wanted to be more sustainable. They didn't want to listen to that generator, and the fuel was becoming more expensive. So they started to be the first people in the industry really to start to use those solar modules that you see on the right-hand side there, lead acid batteries, because lithium-ion batteries really weren't available. That trace inverter that you see up top, and old school kind of charge controllers as well. But that, kind of brings me to the point of this slide, really, that a successful off-grid home, depends on the sum of all its parts, not just the solar and the batteries, but more importantly, the loads and the behavior of the homeowners as well. I do want to, just kind of mention here that up here in Humboldt County in Arcata, California, is where I'm living. There were a lot of people that started distribution companies, Alternative Energy Engineering, or AEE, Backwoods Solar, John Schaefer at Real Goods. These were some of the first companies that started to distribute some of these products as well. And it's hard to tell in this picture, but those are 60-watt solar panels, kind of all laid together. It looks as though that could be just 2 or 3 panels with today's modules. Another kind of home power, and I promise I'll stop showing home power magazines here in a second, but I went back a little bit and found this one from 2008, right? And I found this quote here in one of the articles here is, for decades, cheap propane was kind of the dirty little secret of living off grid, right? You use propane to heat your water, to cook with, to heat your cabin, unless you had a wood stove, but also to run a generator, right? And as years went past, those propane became more and more expensive, and the cheap propane is not coming back. So as we look forward to the future, we see that we're starting to implement more batteries and solar, and going towards those all-electric homes to produce the energy, the heat, the cooking for our homes. So this is an interesting article. And then looking back in the advertisement section of this home power, I found an old NAPSEP ad, and then also a Sunfrost ad as well. And kind of that brings me up with Sunfrost, right? Anybody who's heard of them, back in these old off-grid cabins, a lot of it was DC architecture. We would have DC lights, a DC refrigerator like we made at Sunfrost. And then as the years evolved, inverters became more powerful, batteries became less expensive and more powerful, and then also photovoltaics become much less expensive. So we could kind of just do whole home AC and kind of move away from some of that DC architecture. I'm going to show you here in a minute why that might still be a possibility, or might still be the future if we look at it. Again, lastly, on these home power, what we're looking at here are 2 articles talking about interconnection agreements and how the future of how we send our excess energy back to the grid from our photovoltaic systems has changed over the years. And there was a great article that came out in Solar Builder magazine really recently talking about grid defection. So the idea is that a lot of people think of off-grid homes as up in the woods, in remote areas, and that's still true. But the idea that there's going to be people that have homes that would otherwise have access to the grid in a city or in a suburb who choose not to. They're going to go grid defection. So a lot of the principles of people living with the availability of grid still apply when we talk about somebody on a grid defection, right? They're going to need to provide all the power they need and store all the energy that they're going to need to live off grid, even though they may have access to electricity. So again, all these slides will be sent out to everybody. So if you have a little extra minutes, go ahead and click on that link when you get the slide and go ahead and read that article in Solar Builder. And additionally, Home Power magazines, all of them are available online, and I have the links down there in the bottom left corner as well. So kind of what we're looking at here is understanding I expect a lot of people on this call do understand that, right? You're going to get a lot less energy consumption during the nighttime when you go to bed, and you're going to get a lot more during the day usually, or in the evening, kind of that time of use. Additionally, you're going to get less solar production in the summer, a lot less in the winter than you will in the summer. Of course, at night, you're not going to. So we need reliable, long-lasting batteries to be able to store that excess energy. So this is a picture I got off a Zillow, actually up here in Humboldt County, and we're looking at an off-grid cabin. So as we think about this cabin, you know, a robust off-grid system with batteries, with the generator, with solar, with the ground mount, with the trenching, with the conduit, with the wires, might cost up to $50,000. But it might also cost $50,000 for us to bring in grid. Now, the cost to bring in utility to a property varies. They usually charge by the foot to run that power, whether it's overhead or it's going to be a lot more if it's going to be an underground service as well. Maybe the transmission lines near this property don't have a transformer there, so they're going to have to install a transformer to step down that higher voltage to provide you the power you're going to need. And then also think about, you might have to go through somebody else's property. So what is right-of-way or easements going to look like to be able to bring electricity to this home? So when we think about the cost associated with what it looks like to off-grid a home, think about also versus the cost of what it might take to bring utility onto that home. So when we look at the idea that we're going to do an off-grid system, so an off-grid system, right, we're going to design the system so that it's absolutely going to be able to get you through summer. In the summer, we have a lot longer days, a lot more sun. The sun's a lot higher in the sky. And then, but in the winter, we get a lot less solar insolation. So if I were to size the system to get you through the dead of winter, it's going to be way oversized in summer. So a lot of off-grid homes incorporated generators. So when we do have that winter storm and it's been cloudy for a week and the solar is not recharging the batteries are getting lower and lower every night, we can start up a generator, charge up those batteries quickly, run the generator at its most fuel efficient run point, which is at a higher load level, and then shut that generator off. We can save the noise and the fuel consumption and the maintenance by running a generator, charging up those batteries quickly, and then shutting that generator off as well. And fuel on an off-grid home, some of that property that I showed you a slide, that might be 20 miles down a dirt road behind 3 locked gates. So if you can get a propane truck in, great. You're going to be paying for that delivery, or you might be filling up gas cylinders in the back of your pickup at your local gas station. So it's sometimes hard to get that fuel delivery. And if you have to truck it in, right, what does that look like to be able to drive into town, fill those up, and then drive it back as well? Usually when you have a generator on a system, it's really not running at its most fuel efficient point, right? It's running at just a couple thousand watts to keep lights on. And the reason we install a larger generator than normal, what you would normally be using is a startup motor loads, like an air conditioner. Randy, do we have any questions before we go on? And let me know if anybody is going to be there at RE+. Randy.
Excuse me, there's no questions here per se, just Michael is offering up some more information that might complement what you have there, Daniel.
Okay, great. Yeah, thank you. Feel free to email me. So let's talk a little bit about the types of off-grid systems. And if you think about it, my calculator right here has a solar panel, right? So this, in a lot of ways, is kind of an off-grid system in its most simple form. It has no batteries. It's only going to last. Probably has a little capacitor in there. But if we look at some of the products I have down there on the left, that little solar-powered radio has a little solar panel, a charge controller, a battery, and it has a load, right? That little radio or that little light, that little lantern you see there. Additionally, as we kind of get a little bit more up, step it up a little bit, you look at one of our big Jenny kits, and this has solar modules, an inverter, a battery. And so again, these are kind of self-contained or integrated off-grid systems. And additionally, we see a lot of EcoFlow, Goal Zero. There's a lot of these kind of self-contained off-grid systems where it has an inverter, has a battery, has a charge controller all built in. Jeff Spies put out a real interesting article about this, and where he talks, and again, the article is linked there, where talks about as building and fire codes become more and more stringent every year for these residential systems that we install, that more people might defect from that and move more towards these mobile systems that don't necessarily have the same safety requirements or permitting requirements. So again, check that out here. Great article from Jeff Spies. Stepping it up a little bit, we talk about direct use systems. So this, you might still have this integrated on a system in an off-grid home. And usually when I see these, I think of a lot of water pumping systems. So what you got here on the right, as we're looking at it, you got a couple of solar photovoltaic arrays. You usually have a linear current booster, right? That's going to be able to start up the motor in that pump. It could be a surface pump. It could be a berry pump. And then what it's going to do is when the sun is shining, it's going to pump water uphill, fill a tank that's hopefully on a hill up above your house. If you don't have elevation, you could get a booster pump to provide pressure. That will require a battery unless you power it during the day. But we're going to pump it uphill. And the higher we pump it uphill, the more voltage or the more pressure we're going to get coming down off of that pipe. And then we usually use a float switch to shut that pump off once the tank gets full. And then you go ahead and turn on your shower tap and have a nice cold shower when you're living off grid. I see it also in fans. On the bottom left corner, you see a lot of fans, direct use, right? There's no batteries on these systems. You have a module wired directly to an appliance. But we'll step it up a little bit. We're going to go ahead and add a battery to the system. Well, we can add two batteries. What you're seeing are our 3.8 kilowatt hour batteries. These come in either 12 or 24 volts. And in this example, we are doing a 24 volt battery. So we're going to wire both those batteries in parallel. And we got a couple of photovoltaic panels, and you don't necessarily need a disconnect, but we got a disconnect there. And we're running it into a Morningstar sun saver, and this one happens to be an MPPT. I know back in the day we still used a lot of PWM charge controllers. So we bring the solar right into here, into this charge controller. We're tracking that MPPT. We're going to charge up our batteries. You don't necessarily need this disconnect here. Why? Because our PHI and SimpliPHI batteries have breakers built into them. And then we go ahead and run our loads. And then what I like about this sun saver, the L version, is that it does have a low voltage disconnect. So internal to this Morningstar is a low voltage battery disconnect that will disconnect any loads coming off of this kind of side over here, so that if you leave the lights on or you leave a load on, that it will turn it off before you drain those batteries too low. And I like this Blue Sea Systems kind of fuse block right here. Again, with these off-grid systems, we're going to have to be careful to make sure we're using the proper wire gauge because we don't have as much pressure. We're only operating on 12, 24, or 48 volts, not 120 or 240 like you would see with, 120 L1 to neutral. Notice my refrigerator here, though. I didn't run this off of my low voltage disconnect. One, because this refrigerator, it might on startup, that compressor might draw more than the 15 amps available at that sun saver. And two, a lot of the DC refrigerators had built-in low voltage battery disconnects internal to the system, so we can let the refrigerator shut it off. I promised you I'd talk a little bit more about the future of DC architecture in home, and I came across this great article from NREL where it talked about the idea that USB-C, how we charge our phones. Some of the USB-C can provide up to 100 watts and power over Ethernet. And so the idea is that, yeah, sure, in a home you're still going to have some AC outlets, but what about the idea that you have a lamp and you plug a lamp, and instead of it having an AC plug, you have a USB-C plug, and now you're powering the lamps off of DC. So it's a really interesting article. And why might we do that, right? Because every time you turn AC to DC or DC to AC, you're going to lose something. So if we can take that solar DC, feed it directly into that sun saver, keep it DC, and store it in our batteries as DC, and then we draw that off to use loads, we have a more efficient system than if we had incorporated an inverter to turn that back into AC. Pretty interesting concept. Let me know if anybody is still doing any DC loads in any homes. It's been a long time. But reality is we are going to have an inverter in a lot of systems. So we're looking at here is some, again, we still have that Morningstar. We're going to keep using that Morningstar to charge up our batteries. In this example, though, I added a midnight solar combiner here. And I added an extra battery here. What I like about these 5 3.8 batteries that you see here in the picture is that these, one, that they're 24 volt, which is uncommon in the lithium ion industry, and two, they don't actually have any closed loop communications. They have a BMS, of course, that will protect the battery, but when you're doing a lead acid battery replacement and you got that old trace, you got this old Morningstar, that charge controller or that inverter doesn't have closed loop communication capabilities. So why buy a battery and pay extra for a battery that does, when we can simply make sure that we program the bulk, the float, the absorb, disable, equalize, make sure we get the charge currents and discharge currents dialed in correctly, make sure we have enough batteries so we don't exceed the C rate of the batteries. Go ahead and leverage these 5 batteries. And these have been a workhorse. We've been making them for, I want to say, about 15 years in one version or another, which is an ancient history in the kind of solar photovoltaic, especially the lithium ion battery industry. Got us a Sure Shine Morningstar inverter here. So we're going to be able to still have some of those loads, and we're going to feed a little load center, and we're going to be able to have some outlets around the house. And when I went to electrician school, this is, and I guess I'm getting off topic, Randy, here, but this is the way your outlet should work according to code. Of course, not a lot of people do that. I still have my DC fridge, and I still have some DC light bulbs. Randy, have you ever seen your outlets installed like that? And I'll ask you this: do we have any questions?
No to the first question, but I honestly haven't taken that close of a look. And no questions right now, but some compliments. So, keep
Okay.
up the good work.
All right. Thank you, Randy. We'll keep going. Back in the day, we had separate charge controllers. We had separate inverters. We had separate automatic generators start, your Mate 3S monitoring. The future really has become these hybrid inverters. And on the screen, you have Solarc. And I would argue the Solarc 12K is one of the first hybrid inverters to hit the market. They put all of those parts and pieces into one box. So we've ditched the DC architecture. We still have, I don't know if you really need this disconnect. Again, it's going to be up to your inspector, and you should be getting your off-grid systems permitted as well and inspected. You can see the disconnect for the solar is right there on the outside of the solar. So you might not need that. It depends on what your jurisdiction wants, but we got solar. we got built-in MPPTs coming in, and we were charging up our battery. Now, I've changed our battery up to our 6.6 stacking battery. It's still lithium iron phosphate, but unlike that Phi or the amplified 3.8, this one stacks together. And so we had kind of eliminated the need for any sort of combiners or bus bars. It goes together really quickly. Each one's 6.6 kilowatt hours, so you're looking at just under a 20 kilowatt hour stack right here. We ditched the DC, so we're still just coming right out of that solar, and we're feeding a load center, and we're feeding our AC loads in the home, and we've incorporated a generator. On the bottom right-hand corner, we have our Power Protect 13K generator, and that's going to be automatically controlled by the solar based on the state of charge of the batteries. So a lot of times we've kind of already, usually here, let's get the batteries down to 80% depth of discharge, and when the batteries are at about 20% state of charge, let's go ahead and start up that generator, run it hard, shut the generator off. And that 13K generator is what I chose for this Solar 12K. When we start to get to larger 15K, the Solar 15K, or some of the other hybrid inverters we partner with, I might choose to bump it up to either one of our 18, 22, or 26K generators. And I'll share a little bit more details about that here in the future as well. I like the kind of the all-in-one in a lot of ways. And as I mentioned at the beginning, a lot of this depends on the loads. The loads is what drives the size and the cost of these systems. So as we kind of look in that top right picture, heating and cooling really, not only of the space, but of your water, are usually some of the largest energy draws in a home. So if you got one of those stoves and they're cooking food up top, and they got one of those fans there that's a Stirling engine, I think it might be, that's able to kind of blow that warm heat and drive that. Or maybe you got the Bico washer. Randy, have you ever had to wash your clothes on a Bico washer? But again, if somebody is used to living in the city and they go live off grid, it's going to take some education on our part as an installer to let them know, what to expect in the winter when the batteries are getting low. Maybe don't use as many loads and conserve. And you don't have to go out to your old Trimetrics battery meter and check your state of charge on your battery. There's apps for that now. But maybe do some tasks during the day when the sun is up and the batteries are charged. If the batteries are charged, the loads are satisfied, and the sun's still shining, all of that solar isn't going anywhere. So go ahead and turn on some of those loads and do stuff during the day. Cook that turkey, if you will, as well. And make sure, you understand that if they're going to be adding loads, we might need to look at the system again and, turn off the lights, right, when you leave a room, and conserve. And I truly believe a lot of people, whether it's on grid or off grid, when they get batteries, when they get solar, they start to think a little bit more about conservation. I would say that with the advent of high quality, powerful, less expensive lithium-ion batteries like the ones from Briggs Stratton Energy Solutions, with solar panels being 30 cents a watt, with very powerful inverters, living off-grid doesn't have to feel like living off-grid anymore. Until you have to use a composting toilet. If anyone's used a composting toilet or has one, please put that in the Q&A and let me know, and let Randy and I know. I talked about this, so I'll go a little quicker. But the idea here is that we're going to try and use electricity to heat our water. We're going to try and use electricity to heat our homes. And when we go to RE Plus next month, make it a point to walk around. How many solar thermal companies do we see? And I believe I took this picture at a show maybe last year at InterSolar, and there are still people out there making solar thermal. And you better believe that NABCEP is still issuing board certified certificates for people still doing solar thermal. And in a lot of ways, I still think solar thermal makes a lot of sense off grid. On grid, maybe potentially, on a physics standpoint, it actually is more efficient to, heat water and then fill that tank up there, that thermosiphon tank. But the idea that we have to have pumps and drain back and expansion tanks, and I got to run water pipes all over your house, which you might have already in your plumbing, but up to your roof. The idea here is that with electricity being so cheap, we can use a heat pump water heater. And I think in the background of this picture, that might be a heat pump water heater there. We can use electricity to move heat to create hot water. And the same idea applies to air source heat pumps. So instead of burning wood or propane, we can use electricity to move heat to one place to the other. Some of these heat pumps have become really advanced, especially these inverter-driven compressors. They're able to modulate, and you don't have to have these wall-mounted air handlers or the wall units. There are air handlers where you can have ducted systems where you don't know a difference. So kind of on the second half of this talk, we're going to quickly run through how to size a system. But before we do that, I kind of want to just make sure we set the stage here. Of course, solar panels have a variation in the amount of power they produce. Of course, the temperature coefficients. Randy, do we have a question?
Well, yeah, I think this might be a good point to interject with this question here. So, actually, there's a couple of them now. Will asked, would you consider the Solar 8K from about 2018 the first true hybrid inverter, or is it the 12K for a specific reason?
Oh, that's a great question. And I don't remember the exact history. I think if I remember right, maybe the 8K did come out first. It could have been the 12K. But yeah, I would say that Solar really was the first hybrid inverter that I really knew of, where it put all the parts and pieces in it. And to be able to see these systems, whether on grid or off grid, we warranty our batteries on grid or off grid, just like Solar does with their inverters. And there's a lot of other companies coming to market with very similar things, similar hybrid inverters, but also with these other boxes that can control loads as well. So I don't know. I'm not sure the answer to that, Randy. It's either the 8 or the 12, but again, Solar. Is there another question?
Yes, Greg asked, was the box between the generator and the inverter a disconnect? This was on slide 25.
So we got to go back a little bit.
25, he said.
25. Yeah. So let's see. 20. So I'm not sure. I got my numbers messed up down here, but this box is a disconnect. If this is what he's referring to, if not, email me and we can talk about it. But I would say that our generators do have breakers built into them, and I kind of put in. Usually, I'm always careful to always add extra disconnects because a lot of times they are necessary based on local codes and electrical codes, but every jurisdiction, every inspector is a little different. So I like to put this in there. It depends on if stuff's in line of sight. Other factors come into play. But this is the AC coming in. It has to be 240 volt split phase. And then this is the 2-wire signal to start coming out of that. Was there another question, Randy, or any comments?
There is one more here. Michael says our lowest, let me start over. Michael says our local jurisdiction in Florida advised us to raise the batteries 3 feet off the ground after we mounted in a garage since we are in a flood zone. I assume the 6.6s are not flood resilient. We are 25 feet above sea level, and I assume the batteries are not flood resistant, even though they are designed to be installed outside.
Yeah, that's exactly right. The batteries are not flood resistant, although they are rated for outdoor. What's really nice about those 6.6 batteries is that they are wall mountable. So we do have a wall mount available, and I think I might have some pictures coming up that show that. So you don't have to build any sort of special bracket or shelf or anything. You can simply mount them up on the wall, get them up the height you require. And additionally, those PHI 3.8 and the amplified 3.8s do have a wall brackets that are purchased separately, whereas the 6.6, you have to order a base. It's a wall base, but the brackets all come included, and it's pretty quick install because our wall brackets, are engineered and designed for the North American market, just like our 2-inch knockout on the battery. So we design these things for 6, 12, 16, 24-inch on center stud spacing. We understand that these batteries are going to be used here in North America, so we've engineered them as such. One thing we keep in mind, hey, Randy, anything else, or was that it?
You're good.
Okay, thank you. Keep them coming. These questions are great. Tracking. A lot of times when photovoltaic panels were really expensive, we'd kind of eke out as much as we can by using trackers. We all know, if you point a solar panel directly at the sun, you get the most power. But even if you're off a little bit, you're still think of it a bucket in the rain, right? If you got a bucket in the rain and it's sitting upright, you're going to get a lot of rain. And as you start to tilt the bucket, you're still getting a lot of rain, but at some point, you kind of go past the point at which most of the rain isn't going to hit the bucket. And that's some of the math there that tells you that. And it's the same idea applies with the solar module. Now you look at this roof on the right one, I see a lot of moving parts. I see a lot of gaps between the modules. So really, it's prone to failure. And with photovoltaic panels becoming so cheap, let's go ahead and take some losses and just kind of cover this whole roof with modules, of course, leaving some gaps between the rows so that we're not shading one row to the next. But I remember ZoneWorks. I don't know if anyone remembers ZoneWorks, where they had a tracker that would passively track, and you didn't have any motors. They would track the sun. There's different ways to track, of course, single axis or dual axis trackers. But I would say maybe for an off-grid system, especially if it's a ground mount, maybe do a seasonal adjustment, not a daily adjustment. And so as I was kind of preparing for this talk, I'm sitting here in the old Sunfrost office that I still share with Larry Schusler. I came across this book up in the left-hand side, and this is from 1976, and it's talking mainly about solar thermal, but a lot of the principles still apply. So it's August 28th. So I came here and I designed this for Milwaukee, which is at 43 degrees north. And I'm looking at noon, and right, I think it's a little past noon for us here in Milwaukee, or for you, Randy, in Milwaukee. I kind of look at these numbers here. So this is at latitude right here. I can only find 48 degrees north, which is as close as I get. So we have the panel tilted at latitude. This is latitude -10 and latitude +10. So the idea here is that in the winter, right, the sun's a lot lower in the sky. So let's kick our panels up a little bit more to kind of capture some of that lower sun. And then in the summer, let's kick them a little bit more flat, so that we can capture some more of that sun higher in the sky as well. So, at the equinox, we're here, it's pretty even across the year. But if we come down here and look at some of this winter time, we can see, especially as we kind of go through the day or earlier or later in the afternoon, that it does change. And you can think about doing a seasonal adjustment, or just buy a bunch of extra panels and account for it that way and not have to worry about it. Latitude -15, latitude +15 is what we usually call it. Let's quickly do the sizing, and then we'll kind of finish off with some look at some of the products. That, Randy, in the top right picture is probably one of the very first Solar 12Ks. This kind of goes to show you how long SimpliPHI batteries and Solar have been partnering together. Solar 12Ks look a lot different now. But again, so I should probably update this picture. I like to keep this picture, Randy, just because it shows how long we've been working together. But this is one of our access cabinets. And so the idea here is that you have a outdoor enclosure where we can put a solar 12K up above, anywhere from 4, 5, or 6 Phi or amplified batteries down below. These are the amplified batteries because I see we have these ones do have closed loop communications. They're little Ethernet cables go in between the batteries, and then up here on this yellow kind of Ethernet cable go into the BMS port on the solar. That allows very accurate state of charge monitoring by that solar. That allows the solar to also be pre-populated on certain set points, because the solar can recognize how many batteries are down below. We have some bus bars. I like how we are busing off the negative over here and busing off the positives over here. So we're feeding the battery bank from opposite directions. But let's size the system. We're going to live off grid. First thing we need to do is figure out how much energy in kilowatt hours they're going to use, as well as how much power in kilowatts or watts they might use at any moment. That's going to tell us how many batteries and how big of an inverter or how many inverters we're going to need. Then we're going to figure out how big of a photovoltaic array we'll need. We're going to figure out a charge controller, pick out an inverter, and then talk about wire sizing. So there's a lot of calculators out there. One way you could do it is, if you're off grid, you're not going to have an electrical bill. But if maybe you're an on-grid person and you're doing this, you can just look at an electrical bill, figure out how many kilowatt hours they use per month, divide that by 30. That's going to tell you how many kilowatt hours they use per day. But if they live off grid, we're going to have to kind of do some old math. And I got some loads over here. I'm not sure exactly if they're going to have 10 light bulbs. I kind of put a placeholder in here. And if you want to make this larger, you simply just kind of bump the numbers up, and you can just continue to add loads. So a lot of loads, right? Most loads, they don't run 24/7. For example, a microwave might only, run for 15 minutes a day. A refrigerator, which cycles on and off, is might only going to run 10 hours a day. There's some loads that run all day, right? Phantom loads of a modem of your Starlink, right, might be running 24 hours a day. But what we do is we take how many watts they use, multiply it by how many of those loads are there, and then by how many run hours per day. And that gives us how many kilowatt hours per day. I see 4.6 kilowatt hours per day. Then we look at how many watts they're going to use, which is going to tell us, like, if they were to have all these loads on at once, that's going to be their continuous watt draw. And then if certain loads, like a water pump or like a refrigerator, they're going to have a surge associated to them. And so we're going to want to account for that for the surge. And, this is a relatively small cabin, pretty modest. I'm going to have a propane heater, a propane stove, propane water heater. So again, we're keeping it simple, but if they want more luxury, they can always do that. 4.6 kilowatt hours per day. Remember, inverters aren't 100% efficient, so we're going to account for that. So really our total consumption is going to be 5.1 kilowatt hours per day. We don't want to have just one day of storage. A lot of times you usually do like 3 to 4 or even 5 days of autonomy. Sometimes 2 days of autonomy, but we're going to go with 3 days of autonomy. So we're going to take our 5.1, multiply it by 3, 15.3. And then you can, and our warranty allows you to discharge our batteries down to 100% depth to discharge with unlimited cycles for a 15-year warranty on that 6.6 stacking battery you see in the top right corner. But I still like to do the old 20%, state of charge, 80% depth to discharge. So we're going to do that. We're going to say, look, we need to bump it up so we're not draining the battery. So we're right around 19 kilowatt hours. And it turns out the math is right, that if we have 5 3.8s, we get 19 kilowatt hours. So you're going to need 5 of our 5 batteries in the top right corner, or a single stack of our 6.6 batteries in the top right corner will give us 20 kilowatt hours. Actually, the 6.6 will give us 19.8, so a little closer to 20. So we figured out how many batteries we need. Now we need to figure out how much solar. Now, if you look at this map here, this is averaged for the entire year. So this would be a great one to do a grid tied system. And I know a lot of people maybe, hopefully still look at these maps, but there are so many programs out there from Open Solar, from Aurora Solar that will do all this math for you. But I still like a map to kind of show us the math. This is going to show us average for the year, which is great. The problem is that we need to size this system for winter. And behind me is a map like this, and actually in the back of one of my old AEE catalogs, when we still had catalogs, in the back of these catalogs was actually a bunch of good, useful information like voltage drop tables. But one thing they did have was some maps. And what this map is showing us is the average solar installation for the worst month of the year. In the northern hemisphere, right, this is going to be a December or a January. So if we think about, Milwaukee here, right? Milwaukee, it says it gets 2 hours. Randy, you get more than 2 hours of sun in winter, right?
Sometimes it doesn't seem like it.
Okay, but that's kind of the full sun hours, right? So maybe in the morning the sun comes up, and it's not quite high in the sky, right? And then it kind of gets through noon, it's a little higher than sets, right? So they're not full sun hours. So if you took the full sun hours, you get around 2, which isn't a lot. And I'm not much better over here up in Humboldt County in Arcata as well. So we got to know how many sun hours we get, and then we also need to figure out is how much solar access we have on a roof. Do we have any trees shading or any structures? So this was something I always like to do is get out my old solar pathfinder. Again, there's so many tools out there that can do this from space with LiDAR to measure the height of trees. But what we do is we need to make sure that we can account for any shading that we get. And you can see if anyone's used one of these, I think you know how it works, but you can see here that there's some shading here in the morning. But what's most important is that most of the middle of the day, right in here, is going to be most open. And these vary. This is December, and then this is summer down here. And like I said, there are so many tools, and this is one example here from Open Solar. Open Solar and Briggs Stratton have partnered together. So if you're want to use this tool, we have a link down there at the bottom, and you can create your own account. What I'm kind of showing here, and I'm going to speed it up a little, you don't need the Solar Pathfinder. You don't need to climb up on the roof, because these programs will calculate it automatically for you. Remember, we used 4.6 kilowatt hours per day, right? That wasn't our battery size, and that's our load. But we are going to account for some battery inefficiencies. The efficiency of a battery varies a lot on temperature, but also at the rate at which you're charging and discharging the battery. But we're going to say 4% loss. Our batteries are less than that when at more ideal, slower charge and discharge rates. I'm going to go ahead and knock off a lot for shade and system inefficiencies. And then we only get 2 hours a day. So I said, we need to generate 4.6 kilowatt hours a day. And if I had a 4 kilowatt array, right? If I put 4,000 watts of solar modules out in the sun for 2 hours, you don't get 8 kilowatt hours. You don't get 8 kilowatt hours, especially after some inefficiencies and shading and that battery inefficiencies. So our system's going to have 4,000 watts of solar and temperature of the panel as well. Although the colder it gets, which is I hear it gets cold there out there in Milwaukee, Randy, the panels will get more efficient. So that's what we're going to go with, 4,000 watt array. We need to make sure we choose a charge controller that is capable of handling 4,000 watts. That Solarc is easily able to handle that. On the left, that's the old Midnight Solar system with some of our old 5 batteries. It can handle it. Then we needed an inverter. The Solarc, right, whether you do what's on the left or you do what's on the right, they're the same thing, just an all-in-one. and we can still use our batteries on both of those. We can make sure that inverter is going to handle that, and they can, right? This isn't a very big system. Continuous is only 1,700 watts. Surge is 23. The Solar 8K is easily able to handle this as well. 5K if you only have 120 loads as well. I always like the beer mug analogy for the reactive versus the VA, volt amperes versus just watts. So keep that in mind. That's kind of the concept between resistive loads and inductive loads. If we are going to do some DC loads, and this is my example of I get to talk about sunfrost again. In the top right corner is an old picture. I think that guy is as old as me in that picture there. But when we have DC conductors, especially at lower voltages like 12 volt or 24 volt, right? So we have a sunfrost. A sunfrost uses 10 amps. If it was using at startup, it actually uses a lot less than that when it's running, but it's 10 amps at startup when that surge kicks in. If it was an AC fridge, right, I could run a 15 amp circuit out there. I could use 14 gauge wire, no problem. But if we only have 24 volts worth of pressure pushing that, and let's say it's 35 feet away, I actually need to be using 8 gauge wire because I need to make sure that that pipe or that wire has enough, not too much restriction in that resistance in that wire so that it can push through there. So I found this, right? A 3 to 5% voltage drop is usually appropriate. 70 feet, right? 35 feet there, 35 feet back. I need to use 8 gauge wire. So if you are going to do some of that DC architecture, make sure you get out the old voltage drop calculator tables or a calculator online and look at that. Here's our system. 4.6 kilowatt hours is our load. We're going to have a 20 kilowatt hour battery, 4,000 watts of solar. You might not get exactly there because panels don't always come in the increments that you want. And we got an inverter, and I'm going to go ahead and slap in a 13K generator as well. If I wanted to live off grid, like not feeling like living off grid, I might choose a much larger system here, larger array, larger generator, a 15K, 40 kilowatt hours of battery, and I still get my little app. Again, here's some of the calculators available to everybody. Northern Arizona Wind and Sun does a good one. The NREL does a good one for solar production. And then we'll quickly talk, about the IRA. I do need to update this. As we all know, this is going away at the end of the year. Off-grid does still qualify to the end of the year. There is some future with commercial, with PPAs, leases as well. But get out there, get your contract signed because this is going away. Build that urgency with your homeowners. And I really, truly believe that states and local municipalities will step up to offer more incentives and rebates. And there's a website here, desireusa.org. We'll give you a link to all of those or tell you what it is. Randy, any questions, comments?
No questions here. I mean, just some good complimentary discussion regarding what you're doing today, Daniel, and I second everything that's been said so far.
Well, thank you. Anybody mentioned any off DC or anything, just let me know, Randy, because I love hearing the old off-grid war stories as well. Here's a kind of a quick picture. This is what it can look like to rip out some old lead acid batteries. People love lead acid batteries, because they're cheaper to install, but they inevitably never water them. And they ruin the battery bank after a few years. So to be able to come in and replace them with lithium-ion batteries that are maintenance-free. So we're able to rip out all these batteries and put in just these batteries, and we have the same usable capacity and the same charge rate, right? Discharge rate. These lead acids, we would do usually a C over 20 or a C over 10. With these guys over here, we can do a C over 2. So we're able to still power the home as quickly as it needs to be and for as long as it needs to be by taking out some of these lead acid batteries. Keep in mind, if you got really old inverters and charge controllers, they might not be able to meet the set points like the bulk float or absorb, or some of those set points with that lithium ion needs. So you might have to consider just replacing the whole system as well. Here's what I did, kind of the math on this. And I don't want to spend too much time because we're kind of running out here, but essentially you can take out, that's the math I did on that. You could take out 16 of these T105s and replace it with just 4 of our PHI batteries right here, because you're getting more usable capacity. And then again, we're just talking about, don't look at the upfront price of batteries. Look at how many cycles you can get out of them. And as the competition heats up in this battery market, I would argue looking at the company that's selling you the products. Briggs Stratton, right, has been around for 115 years. We already have batteries outliving our 10-year. Now it's going to be a 15-year warranty. What is that worth it to you to not see some company just pop up and may go away, and you're going to be left stuck with the battery? Although it had a warranty, there's nobody to honor the warranty, whereas Briggs & Stratton, right, is going to be around to honor that warranty. 15-year warranty on the 6.6, unlimited cycles at 100% depth of discharge. We do have kind of cycles that we expect, 6,000 cycles if you're charging it at a C/2 rate. That's, divide that 6,000 by 365, that's like 16 years. If you're kind of hammering on the batteries, 4,500 cycles. So it always used to be in our lead acid battery days, it was always the depth of discharge that determined the life of a battery. And that's still a little true for these lithium ion chemistries, but more so it's the rate at which you're charging and discharging. And a lot of people aren't going to be doing a hour and 15-minute rate, which is what this is here. Usually you charge the batteries up over the course of a day when the sun's up, and you discharge the batteries over the course of the night. Still using lithium iron phosphate. I would say, and that's what most of our competitors are using, but I would say that the sole deciding factor of the safety profile of the battery isn't its chemistry. It's other factors like its cell construction, its case, internal battery management systems, breakers. So we're really proud of the safety of our batteries, and we have the UL 9540 and UL 9540A test report to prove it. That's a great wall-mounted looking picture. Again, Solar, a lot of Solar pictures here, but we definitely have other inverter integrations that we like and we've worked with. 3 minutes left, everyone, so I want to make sure I just kind of get us to the end and get you your NAPCEP credits. I get you the email. The battery still does have a battery monitor, so if we are living off grid and we're one of those Luddites and we don't like the internet, and we don't want to, you can still go out and look at the solar screen. Will tell you the state of charge of the battery, but the battery itself still has a little screen to tell you when it's charging or discharging and state of charge. They stack together very quickly using these connectors here, both power and communication stacked together, and they're held together with little alignment pins. That's the PHI battery that I was talking about at the beginning. No closed loop comms, still available in 24 volts. That's a 10-year warranty. SimpliPHI 15-year warranty. I need to update my slide here on the 6.6. That is a 15-year warranty. And then I believe high voltage, light commercial and industrial is going to become more popular as the tax changes come into effect. And that's where our high voltage batteries come into play. Email me. I'm not the expert on the high voltage, but we do have a whole team that can help you out. Generators, we still make a lot of generators, and I honestly believe that generators play a very important role in an off-grid system to get you through the dead of winter. They can also play a role in on-grid systems, combining the two together. Even in on-grid, when the grid goes down, maybe you don't even have solar, a generator can come on, run, charge up that battery, and shut itself off. Both the 18, 22, and 26 are able to be approved for off-grid use. 18, 22 have full NG max where they don't derate on natural gas as well. As we close out, again, it's easy to install. Definitely have the apps. I want to say, again, the brand. The brand is recognizable. It's also a brand that's going to be around to help support you at the end of the day. All right, everyone, thank you so much. If you're here for your NAPSAP credits, energy storage training at basco.com, energy storage training at basco.com. That's my email for the NAPSAP credits. If you want to email me personally, my email is up there as well. And thank you, everyone, for joining. Randy, any other comments or questions?
Yes, a few of them came in.
Okay.
Greg asked, how did you use the lithium-ion batteries with the older equipment shown? So I'm assuming that's that replacement that you were showing earlier.
Yeah, so we had to. I didn't personally do that system, but I imagine what they had to do was go in there, and we have integration guides. So if I remember right, those are some FM 100s and some old Outback. They might have been Radians. We had to get in there and program, adjust the set points in those charge controllers, in those inverters. So we adjusted maybe the bulk, the float of the absorbed voltages. We made sure we disabled the equalize because we don't want to fry the batteries. And we also made sure that with the older inverters, maybe that 8,000 watt Radian, you can't adjust the discharge of the battery, right? If somebody turns on 8,000 watts worth of loads in the home, we need to make sure that our batteries, there's enough batteries in there that are able to supply the amps that inverter is calling for. So every one of our 3.8s has a 1.9 kilowatt continuous discharge rate. So if I had 4 of them, I'd be a little short of that 8. So I put in 5 there. I hope that answered the question. If not, email me and we could talk more. Any other questions, Randy?
Yes, Michael says here, can you discuss the equipment that uses the DC power efficiently or more efficient than AC equipment? Do EV cars motors run on DC power?
You know, I did go to electrician school and I got a geography degree. That's why I love my maps so much. But I'm not an electrical engineer. So I'm not able to really answer that question, although we can do a little research. I do know that, every time you switch between the two, you're losing something. And I'm not sure on DC motors. I would think maybe something there. But again, I'm not really that expert on it. But I'm going to do a little research. That's prompted me to think about that. And so next time we do this, I'll maybe have a little bit more.
All right, next question here is from Dimitri. It says, what is the weight limit or stack limit on the stack of batteries?
Yeah, so I'm assuming you're asking about the 6.6 stacking battery. A 6.6 stacking battery, each module is about 130 pounds. The controller weighs like 20 or 30. The base is about 9. So you stack all those up. You can only go 3 high, and all of the base and the back brackets are rated. If you're concerned about the wall, you might have to sister up some studs or get a structural engineer, but it can go onto a wall. I will say this, that part of our newer UL 9540 edition 3, we had to go through seismic testing. So not only is it strong enough to hold the batteries up, but even in an earthquake, it's really strong as well. And make sure you follow the instructions on the amount of connectors you need to use proper fasteners to secure it to the wall. Any others?
Yes, Fred asks, can you mount the battery bank on a trailer?
Yeah, mobile applications. So, these batteries, right, they're designed for stationary applications. And if you have a trailer that's going thousands of miles down the road, there's a lot of vibrations that come into play with that. We have seen specifically the PHI and the SimpliPHI batteries be used in trailers. A lot of times I'd like to see like padding or some sort of shock absorber material on the bottom, not necessarily springs or something, but just some padding, and maybe also don't locate the batteries directly under the axles, somewhere else in the coach or the ART trailer. And we've had some great systems with Victron Victron makes some great mobile systems. And that's a great point, Randy. A trailer is an off-grid system. So I think that's something I also maybe include is dig up some old pictures of some trailers with their batteries and throw them in here for a little show and tell. Anything else, Randy?
We have one more from anonymous attendee, if that is your real name. It says, do I have to come to you guys to be a certified installer in terms of training in person for your products?
Great question. So the answer is no. Anybody can install our batteries as long as you have the proper license, to work in your jurisdiction. You don't have to take any of our training to install it, but I would say that after your first install, we will welcome you into our IQ program where you can start to earn rebates. Anybody who's interested in absolutely, we have installer training. I didn't include a slide, I should have, on Power Academy, which is our online learning portal, and you can earn certificates of completion ahead of time of doing an install. And of course, we encourage education, but just to be able to install the batteries, no. As long as you're licensed and insured, bonded, or whatever you might need in your jurisdiction to do that, you're good to go. And we do have certifications if you like it. All right. Anything else, Randy?
That is it for the questions.
Well, I thank you, Randy, for help with the questions. I thank you all for your time. Energy storage training at basco.com for those NAPSEP certificates. Hope to see you all at RE Plus next 2 weeks from now. And take care, everyone.